Okay. Okay, what is the issue that we are actually facing? With electricity consumption keeps growing, we see a lot of new energy being produced from different kinds. We heard about it. And with energy being or growing around the world, actually fault levels on the grids keeps increasing. Fault is a situation when there is a short circuit on the line. If you have more power being pumped into the grid, the short circuit, the current level will rise. Maybe you can move to the next slide. Let's try to advance like this. Okay, here is an example from the UK market specifically. It's a study that was published by Western Power Distribution, showing that already 500 substations in the UK, the fault level, or the prospective fault level, is exceeding 80% of the equipment protection capability. And this is where it's starting to get risky, when you're going above the protection capability. Can you go to the next slide? What is the the common solution that utilities or network operators will do? When you have an excessive fault, it actually disrupts the grid. Equipment may get failed, and in severe cases, we may see power outages, like a very famous case in the north and east of the U.S. a few years back. A fault issue in Ohio actually created almost 3 days of outage in the entire East Coast, cost a lot of money, impacting many millions of people. The next one. What people will do today, either segment the grid, which is counterproductive because you are actually trying to mesh the grid and share the power, or continuously increase or upgrade the capability of the network by putting new equipment, spending a lot of time and efforts and downtime, and this is a very costly process. Next one. Here is what we are offering. It's called fault current limiter. It suppresses the excessive short circuit current. This is how the product looks like. It sits in a substation, can sit in a distribution or transmission or an industrial plant substation. And all its purpose in life is, when there is a fault situation, to actually choke the current level from the perspective it can reach down to the level that the protection equipment can handle. A single FCL can save investments of tens or hundreds of millions of dollars in alternative upgrading, and it's a very straightforward installation and operation, like a typical power transformer. The device is actually, the product is very mature. It's operating in actual networks. Here in the UK, we are in UK Power Networks and Western Power Distribution. The product is working almost 4 years now. It proved to be very robust, very reliable, actually handled quite a lot of fault cases, exactly as we were planning for. And it was successfully adopted by the local DNOs, and there is an interest to look forward on some other opportunities. Next one, please. Here is some quotes. We won't have time to read in details, but in general, UK Power Networks and EON, for example, here in the UK, we're extremely satisfied with the product. This is where it's actually located, in the substation, and the experience was very good so far. What did we learn so far? We gained a lot of experience, a lot of know-how. We actually applied for quite a lot of patents. 5 of them were already granted, so we are trying to be very protected from the innovation perspective, the novelty perspective. We have good understanding of the market needs at this point. We are operating for the last few years. And what we've learned is that the initial product that we introduced to the market a few years back is very well suited to transmission, distribution type of networks, to the utility market. But as we are looking forward, in order to be attractive to smaller, I would say, customers that are dealing with applications in the low to mid voltage level, be it power producers, independent power producers, or industrial type of companies. We need the product to be smaller in size and cheaper, and this is where we focused our effort in the last 2 years. In the original product, we had really a lot of good support from the Energy Technology Institute Fund and consortium, so it was very helpful. But going forward, we've used another grant that we've actually won last year from the European Commission, and we've used it to develop a smaller or a second family of product, which will be smaller and much cheaper in cost. And it starts to be very attractive, and we have ongoing discussions already going with different IPPs, decentralized generation types of companies, and industrial customers. Here's an example of where the FCL can sit in a solar farm, in a wind farm, in a gas turbine farm. When you're looking on industrial applications, a sweet spot is a data center, trying to raise the capacity of energy that it consumes and giving the protection in data center. This is a growing market. All the Googles and Amazons of the world keep on building new data centers around the world, and we see a lot of interest there. Oil and gas platforms, and definitely heavy industries like mining and steel and cement, etc., are prime candidates for this type of product. We foresee a lot of potential business. Utility market obviously moves slow, but long term we see a lot of potential in the utility business, where product price range from our perspective would be around $1 million. When you go to transmission, it's even more expensive products, but we see much faster move with the mid to or low to mid voltage, as I said, with decentralized power generators and industrial, where we see thousands of potential customers in the next few years, and an average price point there is probably even lower than the $200,000. We're looking on products which are in the range of $100,000 to $200,000. We're expecting pretty high margin level, at least initially, and since this type of projects or product sale is a staged payment, it requires really low working capital in most cases. Last slide, I think. Okay, another one. In terms of business model, we are selling direct so far. Introducing this type of new technology takes a lot of evangelism, but we're looking also, and we are developing strategic partnerships with large system vendors, with large integrators, and very important partners for us. And we are in touch with a few of them, is large engineering companies, consulting firms that are actually working on planning the next networks, be it utilities, IPPs, and such. The product is being designed and customized by GridON. We are using subcontractors to manufacture it. As you see, it is a pretty substantial piece of hardware, so we are in partnership with today with Wilson Transformer. It's a transformer manufacturer out of Australia, but we are talking to quite a few other manufacturers around the world. And installation and technical support is being done by local teams. And the last slide, I believe. Yeah. So we are looking on next funding round. We had initial funding, and with some of the grants along the way, we actually crossed the last few years of taking the product from a concept to actual commercial device that sits in real networks. But going forward, now that we have established a lot of credibility and experience with the product, and technology is proven, we really want to go much more aggressive into the market. So we want to invest in more sales and marketing, and local sales and marketing. We want to generate more business partnerships, and obviously continuously developing further product families. And for that, we are looking right now and start a next round of somewhere in the range of $3 to $5 million. That's where we targeting. With that said, thanks, and have a great lunch, and I'll be happy to talk to anybody who finds it interesting from any angle.
Thank you very much.